Hello viewers, Wagodaruna taking you through the story of A-Level Applied Mathematics. And this video we are going to go through the marking guide for U.A.C.E of Uneb for the year 2022. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So this is our agenda so far. What is ticked is what is available on this platform, and what is not yet ticked, it will be uploaded with time. So you start with section A. This paper contains two sections. Section A, which has 8 compulsory questions, and each is 5 marks to make 40 marks. And section B has 8 questions where a student has to attempt 5 questions each with 12 marks to make 60 marks. So 40 and 60 is where the 100 comes from. But in this year, there was something funny with question 7, as we shall look at it. So this question, the way it was set, it had incomplete information, and therefore there's no way we could distribute the 5 marks. So what we did, we had to push the marks to other questions, and these will be question 2, 3, 4, and 6. So as you're going through the solutions or the marking guide, you realize that these questions have 6 marks each instead of 5. And the reason is because they wanted to cover up the 5 marks from question 7. So let's start with question 1. It says a rough plane is inclined at an angle of arcsine 3/5 to the horizontal. A mass of 1,500 kilograms moves up the plane with a steady speed. So steady speed means the acceleration is 0. The coefficient of friction between the car and the plane is 1/4. Calculate the driving force exerted by the engine of the car. So first of all, arcsine 3/5, when you use the calculator, it gives you 36.87 degrees. We use 2 decimal places. Then we can now draw our inclined plane using a ruler. Then we shall put the forces. The first force is of course the weight, which acts vertically downwards. Then we resolve it into 2 components, parallel to the plane and also perpendicular to the plane. The next force will be normal reaction, capital R. Then the driving force, which is up the plane, let it be F. Then the direction of motion is upward, but acceleration is 0 because of the word constant speed. Now, because motion is upward, friction must oppose motion, so it will be in this direction, mu R. Then we can come and resolve. Resolving, because this is 0, it implies that this force is equal to the sum of these 2 forces. So this one is here, and this is here. So mu is 1/4, and the R is this component. Then you can substitute for G. So substitution for G is a must. You have to substitute for G. Then use a calculator to get the output, and that's what they wanted. So I think you realize that these are 6 marks instead of 5, and the reason I've already told you, we wanted to cover up the marks for question 7. So 1 mark for the angle seen, correct diagram drawn with a ruler. This one is for value of R. Then this one is for the component of weight, component of friction, and the output. So like I told you, Uneb releases reports every year, which have what the question required, the weakness of the candidates, and also the advice. So for question, we shall give analysis for every question. So question 1 required you to draw a force diagram when acceleration is 0, and to resolve the forces perpendicular and parallel to the plane and it was a very popular question. So weakness of candidates was failure to draw the correct first diagram and to deduce that acceleration is 0. So each time they say speed is uniform or constant or steady, acceleration must be 0. Then also failure to resolve the directions in the directions of the plane. So we no longer resolve vertically and horizontally. When it comes to inclined planes, we resolve parallel to the plane and also perpendicular to the plane. So I advise that teachers should guide students to draw correct first diagram with a straight edge. So meaning you must have a ruler. Encourage students to deduce acceleration at different stages of speed, and emphasize the proper resolving of forces. So when it comes to mechanics, two concepts you must know them. One is resolving and the next will be taking moments, because most of the things revolve around that, especially in the section of statics and dynamics. Then question 2 says, the table below shows the number of people in each of the 100 cars that pass through a checkpoint on a certain day. So number of people and the number of cars. Find the mean number of people in each car and the variance of the data. So you shall need to tabulate. This is under ungroup data, but because there is frequency, we shall need to tabulate. So values of x are this number of people. Then the frequency are the number of cars. We need to add all these ones and get the total, which will be 100. Then because they ask for mean, we shall need column of fx, where we multiply this with this to give you 41, this with this to give you 66, this with this to give you 54, this with this to give you 24, and this with this to give you 10. Then we need to add all these values to get 195. Then because they ask variance, we need column of fx squared. So f times this squared gives you this 41, this times this squared 132, this times this squared 162, this times this squared 96, this times this squared 50. Then also add all these ones to get 481. Now that we have values of summation of f, summation of fx, and summation of fx squared, we can get the mean and variance. So first of all, mean is summation of fx over summation of f, which is 195 over 100 to give you 1.95. So we need to code the formula, substitute, and get the output. Then when it comes to variance, still we have to code the correct formula, summation of fx squared over summation of f minus mean squared. So I think minus mean squared because this mean was not recurring decimal, it was exact decimal. If the decimals were recurring, we would have put here this very expression. So substitute summation fx squared over summation f minus mean squared to give you this. And that's what they wanted. So B1 was for the column of fx, B1 for column of fx squared with correct sum, substitution, output, substitution, output. So still it is 6 marks, and I believe you know why. So this question required the candidates to find the mean and variance for ungrouped data. And the weakness was candidates interchanging f with x. So you must read the question and realize what is frequency and what is x. Now here, what confused students is that both had the word number. So how do you distinguish which one is x and which one is y? You look at the question. The question said mean number of people. Mean number of people. So what is put here, what becomes x. If they had said mean number of cars, then this would be x. But they said mean number of people, so it's the same as mean of x. Mean number of people means x is the number of people. Don't confuse that. Then they advise that teachers should guide students to distinguish between statistical concepts. Then question 3 was on numerical methods, and it came from the topic of trapezium rule. And it says, use the trapezium rule with 7 ordinates to estimate this integral correct to 3 decimal places. So here when they say 7 ordinates, it means that h will be got by getting the difference between the limits, upper limit minus lower limit, divided by 7 ordinates minus 1. We are saying minus 1 because of the word ordinates. If this was the word interval, we would not subtract 1. But each time they use the word ordinates, you must subtract 1. So that gives you 1/3. Now this 1/3 must be keen. When you want to use decimals, it will be recurring decimals. So if by mistake you write it in decimal, then that is where marking will stop. Why? Because h can never be approximated. So be keen with this. It must remain a fraction unless it's an exact decimal. But for this case, it was not an exact decimal. So don't tamper to make it a decimal. Then you can substitute. We can tabulate now. N denotes number of ordinates. So there are 7, but we stopped at 6. Why? Because we started with 0. 0, 1, 2, 3, like that. So that is why we are having 6. If it is okay to begin with 1, there's no problem with that. Then we shall go to xn. Xn, the first one is this. Then we keep on adding h. So 0 plus 1/3 gives you 1/3. 1/3 plus 1/3. 2/3 plus 1/3. 1 plus 1/3. 4/3 plus 1/3. 5/3 plus 1/3. Like that. So realize that we begin with the lower limit and end with the upper limit. Then next is to use a calculator and substitute in this function here. So when we shall replace x with each of these values to come up with 2 columns. The first column will contain the first and last. In other words, the first column contains the value of y for this lower limit and upper limit. Then in between you shall need another column. So when x is 0, put 0 here to get that. Now here we don't use fractions, we use decimal places, but we should be keen with this word. Because they said 3 decimal places, we must boost accuracy by adding 2 more decimal places. So always remember to boost accuracy each time you are in numerical methods. Then when x is 2, we shall come up with this. And the total is that. Then what about the intermediate ones from 1 to 5? We shall put them in this column. So when x is 1, y is that. When x is 2, when x is 1/3, y is that. When x is 2/3, y is that. When x is 1, y is that. When x is 4/3, y is that. When x is 5/3, y is that. Then you also need to add all these values, and when you add, you shall come up with that. So now that we have finished tabulating, we can quote the formula for trapezium rule. and then substitute. Note that we're using approximate sign. So h is half h, then this one is sum of the first and last ordinates, and in between there is this intermediate ones, which is that. Then shall use a calculator to come up with that. But remember, the question wants 3 decimal places, but we can't immediately write 3 decimal places. We first write the number of decimal places we have been using, then we can round off to the required accuracy. So B1 is for this h, this is for these values of xn, this one is for all these values, but the decimal places must be more than 3. This one is for sums. Then this is substitution and output. So the question required candidates to estimate the approximate value of a definite integral to 3 decimal places. The weakness was failure to interpret the term ordinates. So when they say ordinates, just remember the denominator must be number of ordinates minus 1. Also, failure to use the appropriate number of decimal places. So if you use 3 in the table, it is already not okay. They must be more than 3. Then advice to teachers should help learners to differentiate between applications of ordinates and sub-intervals. So when they say ordinates, you subtract 1, but when they say sub-intervals, you don't. Illustrate to students the use of appropriate number of decimal places during calculations. So in numerical methods, what disturbs students are the number of decimal places. So once we don't agree with what the question wants, then marks have already gone. So now we shall go to question 4. Question 4 says, the diagram below shows a mass of 5 kilograms lying on a rough inclined plane at 30 degrees to the horizontal. From a 5 kilogram mass, a light inextensible string passes up the line of greatest slope over a smooth fixed pulley carrying a mass of 3 kilograms hanging freely. So it's a string through the fixed pulley and carrying a mass of 3 kilograms. The tension in the string is just sufficient to prevent the 5 kilogram mass from sliding down the slope. Determine the coefficient of friction between the 5 kilogram mass and the rough plane. So because the motion has not yet started, it implies that this question is under statics. Remember, statics deals with forces with no motion. And the good thing, they have drawn for us the diagram, so our work is to show the forces. So let's first redraw, because in an exam you will not hand in the question paper, so you have to redraw it. Then you can put the forces. The weight for this is 5g, then its component part of the plane and perpendicular to the plane. Then the normal reaction, capital R. Then next we shall go to tension in the string. Tension arrows must point towards each other. Always, these arrows must point towards each other. Then here there is weight, which is 3g, and also tension. Arrows must point towards each other. Now realize that all of them have T because it is one string. So if the string is still the same, a continuous string has the same tension throughout. So it's preventing it from moving downwards. That's why here acceleration is 0. And also there, since it is rough, friction will oppose motion. So for the 3 kilogram mass, we are interested in these forces. It means that t minus 3g is equal to 3a, but the acceleration is 0, so t is equal to that. Then resolving parallel to the plane for the 5 kilogram mass, the forces we're interested in are these ones. We're interested in this. And acceleration is downwards, so it means that this minus these two will be equal to ma, which is 0. Implying that these two are equal to this. Then substitute for g, for t, mu we don't know it, and for r, which is 5g cos 30. Then use a calculator to get the value of mu, and mu was a negative. So remember, ideally mu must range from 0 to 1. So this question was not well said, but good enough that something could be written. That is why we could not distribute the marks to other questions, though it was not well said. And that's how the 6 marks would be awarded. So question analysis, the question required candidates to determine the coefficient of friction when the connected particles are in equilibrium. However, the direction of frictional force was opposite. That's why you are getting negative, because it was not well set in the values chosen. So weakness is that failure of the candidates to draw a correct force diagram. So force diagram should be drawn with a ruler. To deduce the acceleration is 0. When they say equilibrium, acceleration should be 0. And also to resolve, like I told you, resolving in mechanics, you cannot run away from it. Resolving and taking moments, they are needed. So advise that teachers should demonstrate to students the correct drawing of force diagrams and emphasize the use of a straight edge. So ruler, you can never go to a paper 2 exam without a long ruler, so I encourage you to buy one, because all the marking starts from the diagram, and when the diagram is not okay, then we can't give marks. Encourage students to accurately resolve forces on the inclined plane. So inclined plane, like I told you, resolving is now parallel and perpendicular to the plane. It is no longer horizontal and vertical. Then teachers should encourage students to identify the acceleration when the forces are in equilibrium. So question 5 says, two events A and B are such that probability of A is that, probability of B is that, and probability of A complement intersection B is that. Find the probability of B complement intersection A. So A intersection B probability of A intersection B from contiguous table is equal to probability of B minus probability of A complement intersection B, which is this minus this to give you 1/12. That means that probability of B complement intersection A is probability of A minus probability of A intersection B, which is a half minus 1/12 to give you 5/12. As simple as that. So the first mark was mobile. Mobile means it can be given for this expression or for this expression. Then this one is for this subtraction output. You could also use a Venn diagram. It is still okay. So the question required candidates to find this probability for given events A and B. The weakness was failure to obtain the intersection of A and B, and that's where marks starts from. Then also failure to identify the required expressions from the contingency table. and also wrongly considering the events to be independent. So this word independent, events are considered independent if it is indicated in the question. Otherwise, you must use either a contiguous table or a Venn diagram only. Advice is to emphasize the identification of independent events, and teachers should guide students to use contiguous tables for intersection of events. Then question 6. Question 6 says the table below shows the amount of euros equivalent to US dollars. Using linear interpolation stroke extrapolation, calculate the amount of dollars equivalent to 92 euros. And part B, euros equivalent to $85. So if you look at this 92, you have to know where it lies. 92 euros is outside here, meaning you're going to use these two known values to get the unknown. Therefore, you shall come and extract out those values. So this is called extrapolation because this 92 is outside the given values. So equate gradients, you can equate gradients or quotients. So for me, I prefer quotients where I say this minus this over this minus this is equal to this minus this over this minus that, which are correct quotients. But if you use gradients, it is also still okay. The next is to make x the subject. Then for part B, $85. So this one is in between here, so we shall come and extract out the values. And also use either equating gradients or correct quotients. So correct quotients, it will be this minus this over this minus this is equal to this minus this over this minus that. Then make y the subject. So note that we are using 4 decimal places. Some students are funny. When they see that these values are whole numbers, they will want to give their answer in a whole number. It is not okay. You must boost accuracy. So that's how the 6 credit marks will be awarded. So the question required candidates to use linear interpolation or extrapolation to determine the respective currency denominations. The weakness was failure to locate the necessary values in the given range, and also interchanging the gradients, hence poor computation. So when you are writing those questions, you must be consistent. Advice to teachers is to demonstrate the location of values and also obtain correct gradients for easier computation. So me, I didn't use gradients, but I made sure the values, the quotients are consistent. It is also okay. So this is the question which was not well set, and the why it was not well set was because of this word, relative. So crossing a river deals with resultant velocity, but the problem, they put the word relative instead of resultant. So there, and remember in Uneb, you cannot correct anything. So once you sit for a paper and you realize there's a certain mistake, don't say there's a mistake in the paper. They cannot edit it once it has been printed. So marks were distributed to these questions. Question 8 says, bag A contains 7 red balls and 4 blue balls. Bag B contains 5 red balls and 8 blue balls. A ball is randomly transferred from A to B. A ball is then randomly removed from bag B. Find the probability that Roman 1, a red ball is removed from bag B. Then part B, the transferred ball is blue given that a red ball is removed from bag B. So this question was on tree diagram, meaning we have to come and draw, first make a sketch of how the tree diagram will look like. So they told us that a ball is picked from bag A and put in bag B, after which a ball is removed from bag B. So first of all, let's consider bag A has 7 red and 4 blue, so we shall come and put 7 red and 4 blue. When we pick a red, we shall first consider the case when we first picked red. If we pick red from A and put it in bag B, it implies that probability here will be 7/11. And because this red is put in bag B, we shall come and realize that bag B initially had 6 red and 8 blue, meaning that now it will have 6 red. Sorry, initially it had 5, meaning when you add the red ball, it will become 6. And the blue will remain 8. That means that the probability of picking red from bag B will be 6/14 and blue will be 8/14. That is if we first picked red from bag A. What if we first picked blue from bag B, from bag A? Simply the probability here will be 4/11. And yet means that blue increases by 1 and this remains. So we have 5 red and 9 blue. So picking red from here will be 5/14. And picking blue from here will be 9/14. So that is a tree diagram. Now we shall go to the question. Find the probability that a red ball is removed from bag B. So P red will be, so here there's red here and red here. This red comes from R1 intersection R2, which is this. And this red comes from B1 intersection R2, which is this. So we shall substitute this times this and also this times this. So this bracket gives you 3/11, this bracket gives you 10/77 to give you in the end 31/77. That is part A. What about part B? Part B says the transferred ball is blue. Probably that the transferred ball is blue given that a red ball is removed from second bag, from bag B. So that is B1 given R2. So expanding this gives numerator and then gives intersection in the numerator, and here denominator is what comes after the slash. So B1 R2, we already saw it. B1 R2, we saw it was this, so just transfer it here. Then R2, probability of R2, we already calculated it here, and it was 31/77, which is here. So when we divide, we come up with 10/31, and that's what they wanted. So that's how the marks would be awarded. So the question required candidates to find probabilities that a red ball was removed and that the transferred ball was blue, given that the removed ball was red. So weakness is failure to consider the increase in the sample space in the second box. And 2 was failure to apply conditional probability theory. So advise that teachers should expose students to various probability situations leading to changes in the sample spaces. And 2, to illustrate the application of conditional probabilities in relation to the sample considered. So that was question 8. Now we shall go to question 9, which is section B now. So question 9 is from correlation and says The table below shows the marks of 8 students A to H in 2 tests. So these are the students, these marks in test 1, marks in test 2. Part A, Roman 1, plot a scatter diagram for the given data. Roman 2, draw a line of best fit on the scatter diagram. Roman 3, use your scatter diagram to obtain a mark in test 2 which corresponds to a mark of 63 in test 1. Then B, Roman 1, calculate the rank correlation coefficient for the data. And Roman 2, comment on your result. Now, something funny with these questions of correlation, each time they ask you to draw a line of best fit, it means they want you to get a mean point. Therefore, the easiest way of answering this question is to first tabulate everything you'll need to use in answering this question. So we are going to tabulate. The first column will be for the students A up to H. Then next we will put the marks in test 1, which will be X. Then we shall add all these ones and put the total here. Then also put the marks of test 2 and call it Y. Then add everything here and put the total here. So now we shall begin to rank. Ranking means we rank in descending order. But these two are identical, so the would-be position would be 1 and 2. So the average of 1 plus 2, 1 and 2 is 1.5. So both of them will get 1.5, 1.5. The next will be 73, which is position 3. Next would be 64, 7, which is position 4. Next is 50, which is position 5. Next is 44, which is position 6. Next is 42, which is position 7. And next is lastly 40, which is position 8. So that's the ranking for X. What about for Y? For Y is still the same rank in descending order. 1 is 82, followed by 80, followed by 78, followed by 70, followed by 64, but 64 has 3 identical values. So 1 would have been 5, then 6, and 7. But because they are identical, we get the would-be average. So the average is 5 plus 6 plus 7 divided by 3 to give you 6. So each will take 6. So this will have 6, 6, and 6. The next is 52, but because this is 7, position 8, 7, this will be now 8. So there we have ranked. Next is to subtract. So Rx minus Ry, this minus this, 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 then minus that. Then next we need to get the square of those values of D. So this squared, this squared, this squared, this squared, this squared, this squared, square this, square this. Then the total, add all these values, you will come up with this. So that is the tabulation which will help us answer all the questions on this question. So now that we are done with the tabulation, we can answer the questions. The first question was that we plot a scatter diagram for the given data. So there we shall need a graph paper. So we shall come here and get a graph paper. Then we need these values, so we shall choose a correct scale, draw the horizontal axis. I think we realize that I'm leaving only 1 centimeter here. Some students are funny, they draw the axis here and they leave all this space unused, so it's not okay. Do the same for the vertical, leave only 1 centimeter just to a space where your words can fit the figures when you're labeling. Then you can get a scale for the horizontal axis so that all these points fit. So do the same for you have to label it, test 1, then do the same for the vertical axis, get a scale so that all those points fit. And that will be test 2. Then you can start plotting. The first one for student A is 67 corresponding to 82, which is this. Then student B, 73 corresponding to 70, which is this. Student C, 50 corresponding to 64. Student D, 74 corresponding to 78. 42 corresponding to 52. 44 corresponding to 64. 75 corresponding to 80. So you need to be keen when you're plotting. 40 corresponding to 64. And then, so there we have plotted our scatter diagram. That's what they mean by scatter diagram. The next was draw a line of best fit on the scatter diagram. So line of best fit, we need what we call a mean point. So mean point is the average. Good enough we have summation x. Our aim is to, what we need to do next is to divide. So summation x over n gives you that 2 decimal places, because 2 decimal places are the ones which are plottable. Then also x bar, and that would be the mean point. So you come and plot it on the graph, and then draw a line of best fit with a positive gradient. We are going to find out how you can realize that it has a positive gradient from the calculations. But we should know that, so if you draw it in this form, it is not okay, and it must be drawn with a long ruler, leaving equal or almost equal points on either side. Here the points are 3. What about here? The points are also 3. So it is a good line of best fit. That was Roman 2. What about Roman 3? Roman 3, use your scatter diagram to obtain a mark in test 2, which corresponds to a mark of 63 in test 1. So that is estimation. We shall go to test 1 and look for 63, then draw a vertical line up to meet the line of best fit, then draw a horizontal line to meet the vertical axis and read off that value, which is 72.25. So that's what your rate. And that was part A. So let's see the marks. So B1 for mean point, B1 for estimation, B1 for axis and scale, 2 B1s for plotting. So I think you realize that you must be careful when you are plotting. So if this point is wrongly plotted, it means you'll get only B1, and this one can't be got, this one can't be got. So you should be keen when plotting. That was part A. What about part B? Part B, calculate the rank correlation coefficient for the data and comment on your result. So here you shall come and quote the formula from the logbook, substitute and get the output. The next is to comment. So either say significant at 5% or insignificant at 1%. Now, how do you know when to say significant or insignificant? They will get it from the logbook. So the logbook has a part which has significance levels of correlation coefficient. And our interest is this one, we don't need it, and this one for now it will appear in the new curriculum, but for us we need this Spearman's rank correlation coefficient. So when n is 8, you'll come and put your ruler here. The values of interest are this and this. Now you're going to compare those values with the calculated value, which is 0.7789. So 7789, it is greater than this but smaller than this. And here it says significant if that value of calculated exceeds the value in the table. So at 5%, the value of calculated exceeds this. That is why we say significant. But when you look at 1%, the value of calculated is smaller than this. So when it does not exceed, you will use the word insignificant. And that's what they wanted. So the question required, part A required you to plot a scalar diagram, draw line of best fit, and determine value of a test given the other value. Part B required you to determine rank correlation coefficient and comment on it. The weakness was failure to use an appropriate scale for the scatter diagram. That's why I told you that you leave a very small space just where you will write your figures. Then also failure to accurately compute ranks in order to determine the correlation coefficient and give suitable comment. Advise that teachers should expose students to proper ranking process and illustrate to students how to label axes, use uniform scales, and draw accurate scatter diagrams. Teachers should guide students on how to give comments with reference to mathematical table. This is because in principal math, the comments so this is because in principal math, the comments must come from the mathematical table. So in subsidiary math, they still allow where they say high positive correlation, low positive correlation, very low positive correlation, moderate, like that. But in principal math, we cannot allow that. Comments must come from mathematical tables, or what we call logbooks. So take note of that. So now we shall go to question 10. Question 10. This is a question from mechanics and says, a particle of mass 4 kilograms initially at rest at the point A, which with coordinates 2, -2, 3 meters. The particle is acted upon by a force given by this, where t is the time in seconds. Find part A, acceleration in time t, part B, speed of the particle after 3 seconds, and part C, displacement of the particle after 3 seconds. So when the force has t, it implies that it's variable, and therefore need to use methods of calculus to answer such a question. So first of all, we know that F is equal to ma from Newton's second law, so we shall come and substitute for F and for m so that we can get the value of A. So when you take this 4, this side becomes a quarter, so a quarter times 4 gives 1, remain with t. A quarter gives you 0.25 here. A quarter with this gives you 1.25. Don't forget the units. In mechanics, units must be seen. Then for part B they want the speed of the particle after 3 seconds. Remember, speed is the magnitude of velocity. So to get velocity, I'll integrate acceleration with respect to t. When I integrate this, gives you 0.5 t squared. This gives you 1/12 t cubed. This gives you 1.25 t. But don't forget the constant of integration. And this constant is funny. It must have a tilde to show that's a vector. Then remember that initially the particle was at rest, so it is 0, 0, 0. So realize it is not just v equal to 0, it is v tilde equal to 0, 0, 0, because velocity is a vector quantity. So I'll come and substitute for v and t to come up with c as 0, 0, 0. Then that means that velocity is given by this. So it is true that this one is 0, 0, 0, but this substitution must be seen when you are attempting to find the constant of integration. Then after 3 seconds, t is equal to 3, so substitute for t here, here, and here. Then you'll be able to get the velocity. But remember, they asked for speed, so I need to get this magnitude. Now before we go to the next slide, we shall show the marks for this slide. So there are 6 marks for this slide. Now we shall go to the next slide and get the speed, which is the magnitude. Then part C, they wanted displacement of the particle after 3 seconds. Remember, displacement is a vector quantity. So displacement is got by integrating velocity from what? From 0 up to 3, because they said after 3 seconds. So when I integrate, I'll come up with this, and I substitute limits, upper limit to give you this, then lower limit is 0. Simplify to get the velocity, which is the displacement. If they had asked for distance, we would get the magnitude, but they only asked for displacement, meaning you can stop there. And that's how marks would be awarded. So the question required candidates to calculate acceleration, speed, and displacement of the particle after a given time. And the weakness was failure to integrate acceleration, velocity, and inclusion of the constant of integration. When this constant of integration is not there, then your work for integrating will be in vain, because we cannot give a mark. Then advice teachers is to illustrate integration process with or without limits. Then question 11 now, part A. This question is from numerical methods under the topic of errors. So question part A says, two numbers small x and small y are approximated by capital X and capital Y with errors delta x and delta y, respectively. Show that the relative error in approximating this by this is this. So the logic here, the case of the letters in the required proof is the approximate. So here that means that uppercase letters are approximate values and lowercase letters are exact values. The reason why we emphasize that is because the first mark comes from the definition of error, and the definition has to be correct. So let's start with part A. Part A, the definition is that error is equal to exact minus approximate. Then we eliminate the exact because in the proof they only want approximate. So small x becomes capital X plus delta x. small y becomes capital Y plus delta Y. Then we get LCM. At this step we got LCM, and here we open this bracket to get this. Now here, to bring in the assumption, we had to pull out one y, so that this remains with 1 plus delta y over y, so that this one can become negligibly small. Then how do we remove it? We shall come and say that assuming delta x is much less than x and delta y is much less than y, it implies that this delta y over capital Y approximates to 0. So this approximates to 0, and we shall remain with and here realize that this and this cancel, so we have this minus this, and denominator we have only this times 1. Therefore, now that we have got error, we can get relative error. But remember, relative error is absolute error, absolute divided by approximate. So why am I emphasizing absolute? Is because this magnitude sign must be seen. Then this division, for it to become a multiplication, this becomes a reciprocal. Then we bring in it inside. So this one, I'll first split the numerator. When I split the numerator here, now let's see, how did we move from here up to here? 1, this 1 over y squared, and this, you realize that 1y goes away, so denominator becomes now xy. Therefore, y delta x divided by xy, y cancels, remain with delta x over x. Then x delta y divided by xy, x cancels, remain with y delta y. Then we bring in the triangular inequality. That's when you can split the terms. That means, and after splitting the terms, it means that this inequality says less or equal to. So meaning that the relative error cannot exceed this, because it is always less or equal to this value. Meaning this will be the maximum value for relative error. So for you to bring in the word maximum, it should be after triangular inequality. And basically that is what they wanted us to prove. Then for part B, let's see the question. Part B says the values of the expression capital T equal to this are rounded off correct to the given decimal places. Determine the interval within which the exact value of T can be expected to lie. That means you have to get the maximum and the minimum value of this quotient. Good enough, it's a positive quotient. So such questions of error arithmetics, the first thing to do is to state the individual errors in each. Think realize that these are 2 decimal places and 2 zeros. 3 decimal places, 3 zeros. So that is what you should do first. Then you can now get the minimum and maximum. To minimize this quotient, it means that the numerator is minimum, that's why there's a minus, and the denominator is maximum, that's why there's a plus. So come up with this. Then to maximize, it means that the numerator is maximum, that's why there's a plus, and denominator is minimum, that's why there's a minus. To come up with this. Then you can write your interval in that form, box bracket. It must be box bracket. If you use a curved bracket, it's not okay. If you use a curved bracket, it is not okay. It must be a box bracket. Other ways of writing interval can be that this dash this, or you can write in words this to this, or you can write in terms of inequalities. Any is okay. And that's how we could get the 6 marks. So part A required candidates to show the given relative error expression in approximating the given quotient. And part B required candidates to determine the interval within which the exact value of the given quotient lies. Weakness was failure to indicate the appropriate character case for the unknown letters. So when you interchange the case of the letters, it is not okay. And like I told you, the easiest way to distinguish is look at the required expression. If they used uppercase letters, it implies that the uppercase are the approximate. If they used small lowercase, it means that lowercase are the approximate. Otherwise, everything will not be okay. Then to distinguish between interval and limits. Limits, it means maximum and minimum. But if you realize this, let me first show you. Now, if you stop here, it means you have got limits, where this is the lower limit, upper limit. But when they say interval, they want you to go a step further and write in this form, or in one of these forms. That's the difference between limits and interval. Then advised teachers should emphasize the proper use of either capital or small letters in the expression. So should know whether capital letter is approximate or exact, and whether small letter is approximate or exact. Then teachers should guide students to accurately eliminate errors with higher powers by approximating them to 0. So that approximate sign is needed. This one. This sign is needed. So it is a little contradicting with one of pure math, because pure math, they accept you to use the word 10 to, especially when you are differentiating from first principles. But when it comes to paper 2 and numerical methods, this symbol is not needed. They want approximates to 0. So there's some divergence, but in both papers, so you should know them. In paper 1, it's allowed, but paper 2, it is not allowed. Then teachers should enable students to distinguish between interval and limits within which a value lies. I've already talked about that. So now we shall go to question 12. Question 12 says, a discrete random variable capital X has a probability distribution function given by this. Find part A Roman 1, the value of the constant k, the mean of x, the variance of x. And part B, determine the cumulative distribution function and sketch the graph of capital Fx. So let's start with part A, Roman 1. So we shall need to tabulate. So discrete, it is easily done if you tabulate, especially when they ask for mean and variance. So x values, we shall use this given function. Do you see this? There is 1, 2, 3, 4, 5, 6. That's what you shall write in the column of x. Then you shall go to probabilities. Now probabilities, from 1 to 3, we shall use kx squared. So that means that 1 squared times k gives you k, which is here. 2 squared times k gives you 4k. 3 squared times k gives you 9k. Then for the other 4, 5, 6, we use this expression k in brackets 7 minus x everything squared. So we are going to come and say, first of all, For this one, we shall say 7 minus 4, which is 3. 3 squared is 9. 9 times k gives you 9k. Then 7 minus 5 is 2. 2 squared is 4. 4 times k is 4k. 7 minus 6 is 1. 1 squared is 1. And 1 times k is k. So that's how we generate the probabilities. Then we add all these ones to get 28k. Now we need to get the value of k, so we shall come and remember that total probability is equal to 1. So 28k is equal to 1, implying that k is equal to 1 over 28. So that was Roman 1. Now we shall go to Roman 2. Roman 2, they want the mean of x. So good enough, we have got the value of k, so we shall come and substitute for k. And therefore we shall generate another probability. Where there is k, we put 1 over 28, 1 over 28 to get 4. This is 9 over 28, 9 over 28, 4 over 28, 1 over 28. When we add everything, it should be 1. Then we can get x, probability of x, multiply this times this, 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 this times this. Then add everything here to come up with 3.5. That means that your mean is 3.5. So we're done with Roman 2. Then Roman 3, they want variance. Variance, we shall need a column of x squared px. So this squared times this gives you 2 squared is 4 times this. 3 squared is 9 times this. 4 squared is 16 times this. 5 squared is 25 times this. 6 squared is 36 times this. Then we shall add everything here to give you that. Then you can come and say that the variance is given by that formula. Substitute. This is ex squared. Ex is here, but it has to be squared to give you that. That is variance. The next was determine the cumulative distribution function. Cumulative distribution function is we have to put a column of capital Fx, whereby we keep on adding, so we shall begin with this here. Then this times this, sorry, plus, because cumulative means we keep on adding, it gives that. Then this plus this, we come up with that. That plus this, we come up with this. Plus this, we come up with, plus this, we come up with, which is 1. So that is the cumulative distribution function. Then next they told us to sketch the graph of capital Fx. So before we go to the next slide, let's first see the marks for this slide. So far we have got 10 marks. We need 2 more from the graph. So we shall come here and first draw the axes, label them. Horizontal, vertical axis, label it. Then put the necessary values only. So do the same for the vertical. Vertical, we need only these values, so that's what you shall put. Remember, it is a sketch. Then we can now draw our graph. Then 2, when x is 2, probability cumulative comes to this. When x is 3, cumulative comes to that. When x is 4, cumulative comes to that. When x is 5, cumulative comes to that. and when it's 6 and above, so above we put an arrow. Okay, so that is the graph, and that's how we could get the 2 remaining marks. So part A, required candidates to determine the value of the constant mean variance of the random variable given the probability. Then part B, required candidates to determine the cumulative distribution function and also sketch the graph of the function. Weakness is that some candidates considered a continuous random variable instead of discrete. So discrete is when we tabulate, but some candidates chose to integrate. When you integrate, it means it is continuous, but this time it was not continuous. Then also failure to determine the value of the constant, mean, and variance, and failure to obtain capital Fx, and hence they could not sketch the graph. Advice to teachers is to enable students to distinguish between discrete and continuous random variables, and also demonstrate the proper use of the relevant statistical formulas. Guide students to rewrite functions after obtaining the value of the constant. As you can see here, I think you realize that in my table, I have 2 columns, but both have probabilities. It is okay because, why are they 2? Because one had a constant, then the other one was rewritten without a constant. That is what is advisable. Then emphasize to students to label axes, draw lines and curves of the sketches. So you have to use a ruler to draw those axes, and they have to be labeled. We shall now go to question 13. It says forces of magnitude these ones act along sides this, and that. So you say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it is okay. Where ABCD is a square of side 2 meters. Find Roman 1 the resultant force, and Roman 2 the equation of the line of action of the resultant. So that is a square. Labeling should be anti-clockwise. Don't interchange. Then we shall start 2 corresponds with AB. So AB we shall put 2. Then 2 corresponds with BC. So BC we shall put 2. 3 corresponds with DC. So DC we shall put 3. 4 corresponds with AD. So AD we shall put 4. 2 root 2 corresponds with SC. So we shall put it there. Then root 2 corresponds with DB. Okay. Then we can now resolve. Remember, so resolving, this one is entirely horizontal. This one is entirely vertical. So it is 0, 2. This one entirely horizontal. This one entirely vertical. But these other 2 are not. So this one is at an angle, because it's the square, it will be 45. That's why you have this cos 45, sin 45. This one also at an angle, so this cos sine. But there's a negative here. Why? It is because when you come here, the right angle you draw will be this side horizontally and downwards vertical. So downward vertical is negative. That's why you see a negative there. Then use a calculator, you come up with this. Then you can get the magnitude. Remember, force is a vector quantity, so you shall get magnitude and direction. Before I go to the next slide, let's see the marks for this slide. Okay, now we shall go to the next. So we shall come and draw a right angle triangle, positive horizontal, positive vertical, then line from start to end will denote the resultant. So tan theta is equal to opposite over adjacent, which gives you the value of theta. Then we can conclude. So now we shall go to part B. Part B, they want the equation of the line of action of the resultant. One, we have to take moments about the origin, which is now A. So we have 2 times 2 minus. So this is positive 2 times 2 minus 3 times 2 minus root 2 times 2 sine 45. How do these values come about? Let's start. So 1, the general formula for taking moments is FD sine theta, where this is force, this is D, this is the pivot, and this is the angle. So we shall use FD sine theta. The special case is when the angle is 90, because sine 90 degrees is 1. So they will just say F times D, where D is the perpendicular distance. Now this square is of side 2 meters each. So when you look at this force, the pivot is here, so the angle is 90. So we have something like this, where this is 90. So the moment will be 2 newtons times the 2 meters. That's why you saw 2 times 2. Then for this one, the pivot is here, the force is this side, which is 3. The angle is 90, which is this, and the distance is 2 meters. That's why you saw 3 times 2. Then the root 2 here, it is like this. The force is here, which is root 2. The angle is here, which is 45. The distance, the pivot is here. The distance is 2 meters. So here the angle is 45. We shall use FD sine theta, which becomes force, which is root 2, times D, which is 2, times sine theta, which is 45. So that is where the root 2 times 2 sine 45 came from. What about the sines? So we have known where this came from, this came from, this came from. But what about these negatives? Now, by convention, anti-clockwise moments are positive, while clockwise moments are negative. So if this is the pivot, okay, did we talk about this before? We didn't. Now there's something we realized before we go to the signs. Let's go to this and see. Here we have only forces 2, 3, and root 2. The others were not included. Why is it so? It is because if a force passes through the pivot, its moment is 0. Now if you look at this force, it passes through the pivot, so 0 moment. If you look at this force, it passes through the pivot, so 0 moment. If you look at this force, it passes through the pivot, so 0 moment. That is why they were not included. For this one, it doesn't, this one, it doesn't, and this one, it doesn't. That's why there are only 3 forces. Okay, now we shall go to the directions. I said by convention, anti-clockwise are positive, but clockwise are negative. Okay, now if this is the pivot, for this force, it will cause this moment, which is anti-clockwise. That's why it was positive. But when we come to this, if this is the pivot, the moment here will cause clockwise moment. So clockwise means it is negative. That's why there was a minus. Same applies to this. If I'm here, this force will cause clockwise moment. That is why there was a minus. So that explains why we have minus here and minus there. So next is to use the calculator. I'll come up with -4 Newton meter. Like I told you in mechanics, we need to see the units. Now that I've got moment, I can get the equation of the line of action from the general formula, and I substitute. This is this, x is left, then Fy is the vertical component of the resultant, then Fx is the horizontal component of the resultant. So, and that will be the equation of the line of action of the resultant. So don't forget to state the resultant, the direction of the resultant. Part A required cadence to find the value of the resultant force of the given forces along the sides of the square. Part B required cadence to determine the line of action of the resultant. And the weakness was failure to draw the correct diagram with a straight edge. Straight edge means you have to use a ruler. Then resolve horizontally and vertically. Failure to resolve horizontally and vertically. And failure to take moments about suitable points. I told you in mechanics, the two concepts you need to master is resolving and taking moments, because there's no way you can run away from those two. Advise encourage students to draw force diagrams with straight edges. So you must get a long ruler. I encourage you to get a new long ruler before you enter your math exam. Then guide students to resolve horizontally, vertically, and to take moments about suitable points in order to obtain the line of action of the resultant. Then question 14 was on numerical methods and street diagram. It is flowchart. It says the taxation system in a company is such that the tax T based on the amount A and falls in three categories shown below. One below $2,000, bid from $2,000 to $5,000, and above $5,000. This is the tax paid here, no tax paid here. The tax paid is given by that function, and here the tax paid is given by that function. Then they said parts of a flowchart for computing tax are given below. Part A Roman 1, arrange the given parts to form a complete logical flowchart. Roman 2, state the purpose of the flowchart. And part B, perform a dry run for the flowchart and complete the table below. Now we shall start with part A Roman 1, where they want you to arrange the given parts to form a logical flow chart. Now such questions, actually you are not allowed to write on your question paper. You are not allowed to write on a question paper, but for me, because this is a video, I'm going to write some small words. But for your case, you are not allowed to write on the question paper. Do everything on the booklet and leave the question paper as clean as possible. Now for me on these ones, I'm going to first put numbers to show the order of the boxes 1, 2, 3. So that when I go to draw the diagram, I don't draw a flowchart by trial and error. I've been able to know that from here I go to this, from here I go to this. Like that. So always, the first button is called a start. That is always. Then next we look for a read. But before a read, there is this initial value of n equal to 1. So that's what will be our next. Then from there we shall read our value of A. A is the amount. Remember, we are under taxes. A is the amount. N means the number of taxpayers, or the number of people whose taxes are being computed. Then after reading, what next? After reading, we shall go to a decision, because now that I know A, I have to ask myself, where does A lie? Because we saw in this table that different amounts have different ways of computing, but the starting one is below $2,000. So that's why we start with that decision, that is A below $2,000. If yes, what do we do? If no, what do we do? Now, if it is below, the next, if yes, it means you have to compute tax using this t equal to 0. So we are going to look for t equal to 0, which is this, and that will be 5 for yes. What about if no? If it is not, we shall go to the next. Is A between from this to this? So we're going to look for that decision. And the decision is here. So this is 5 for no. So where if this no will connect to this decision. Now this one also has two arrows, yes and no. If yes, we shall look for this one, this assignment, t equal to 2a over 100. So where is it? That one is here. So this will be the 6 for yes. If no, we shall go to this otherwise, which is this assignment. So we're going to look for it. No, we shall go to this. So I look through, I'm now left with how many boxes? There's a box of print, increase the number of people, to find out whether the number of people I want maximum has been reached, and also stop. Now, after calculating the tax, I expect you to write it down. So I'll print, the next will be printing. And after printing, I'll ask, have I reached the maximum? And here it has yes or no. If I've not yet reached, I'll go to increase. If I've reached, I'll stop. So yes, I'll stop. No, I'll go to increase. And I think we have labeled all our boxes. Now, those are the ones, that is the order in which we are going to draw. So arranging these flowcharts is not by guesswork. You have to first look at all the flow boxes given and come up with a logical flow before you draw it down. Then 2, a flowchart must fit on a page. It shouldn't cross from one page to another. That is not allowed. So if you have written halfway of your solution, then go to the next page and draw your flowchart there so that it is able to fit. Now shall come and draw it in order. The first one was start. Followed by n equal to 1. Then from there we went to read. From read we went to the decision. Is n less than 2000? If yes, we compute the tax. If no, we ask, is n less than or equal to 5000? If yes, we compute the tax. If no, we use the only last option, which is that. Then from there, we have to print. We print t and amount for all, either this, that, and also that, all options. Then from there, we have to ask, is n equal to 200? If yes, we stop. But if no, we increase the number. And after increasing the number, we go back to the amount to read A. So basically, that is your flow chart. And that's how marks were awarded. Next was stating the purpose. So that is the purpose of the flowchart is to compute and print the tax paid for a maximum of 200 people and the corresponding amount earned in dollars. So now we shall go to part B. Part B, they gave us this table and you have to complete it. Now because it's an exam, you have to redraw this table in your answer booklet. So I'll come here and first redraw it. Okay, then I'll start. When n is 1, a is 1,500. So I'll come here and ask myself, where does it take me? I've got here 1,500. So where do I go? I should go in the yes. So from here I'll go to yes, where t is equal to 0. Therefore I'll come here and say that my t is 0. What about when I read and it is 3,500? I'll go back here. Here I have read and it is 3,500. What do I do? Here I'll go to no. So no, I'll take me here and here to take me to yes. So I'll say 2 times this divided by 100. What does it give me? It gives me 70. Then what about if I read and it is 9,000? So I'll still do the same. Come here. In your read, it is going to be now 9,000. 9,000 here takes me to no, which is here, and here takes me to no, which is here. So I'll put 9,000 here. So 9,000 minus 5,000, it is 4,000. 4,000 times 5, it is 20,000. 20,000 divided by 100, it is 200. Then 200 plus 60, it is 260. So that means that my t will be 260. So I'll come here and put 260. So the question part A required candidates to arrange the given parts of the flowchart in a logical order and state the purpose of the flowchart. And part B required candidates to perform a dry run for the flowchart by completing the given table. So weakness was failure to identify the starting, middle, and final diagrams. Then use of arrows to indicate the directions of the flowchart. Arrows must be seen. Then also stating the purpose was a challenge, and also performing a dry run was a challenge. Advise that teachers should expose students to different types of flowchart. Then also demonstrate the logical flow of information in the charts. And emphasize performing dry runs. Question 15. 15 says, the masses of packets of tea leaves are normally distributed with mean this and standard deviation that. Part A, if a packet of tea leaves is chosen at random, find the mass exceeded by 7% of the packets. So 7% is a fraction, which is a probability, and is 7 over 100. So shall come and say that let x1 be the required mass. So probability of x greater than, because they said exceeded, greater than x1 is equal to that. Standardize to get z greater than z1 equal to that. So the normal curve, standard normal curve will be in that form. We have z1 and greater than is that. probability of 0.07, and the balance to give you phi is that. So that 0.43 is what we shall look for in the cumulative normal distribution table. So you realize that a value closer to 0.43 is this, because from here it is above 0.43. That's why we take this. Now, after getting a value slightly less than the given probability, come and get the difference. The difference is 0.0008. Now, this digit of 8 to make 4 decimal places is what you look for in the add column, which is, and it comes from 6. Okay. What about this one? Came from 1.47. Therefore, the Z value would be 1.476. So that's how they get Z value. So you're coming and say that Z1 is, from that, Z1 is that. Therefore, expand Z1 to give you X minus mean over standard deviation. Then get the value of X1. And that's what they wanted. Then part B says, if 1,000 packets of tea leaves were sold, find the number of packets that weighed less than 545 grams. So X less than 545, you standardize to get this. Then you draw your normal curve, standard normal curve. It's a negative and it's less. So that probability is that, and this one is 0.5 minus phi 2.75. So when I get this, I can easily get this shaded part. So this one is good from the cumulative normal distribution table. So 2.75 is 0.4970, which is here. Then when I subtract, I get 0.003, which is the probability. But the question said what? The question said if 1,000 packets of tea leaves were sold, find the number. So I multiply the probability, because probability is the fraction of something. Probability times the number of packets to get the required number of packets, which is 3. And that's how marks would be awarded. So question, part A required candidates to determine the mass exceeded by 7% of the packets, and part B required candidates to calculate the packets that weighed less than the given mass. Weakness was failure to identify the proportions in order to obtain correct Z values. Then also failure to calculate probability greater than the given mass and hence the number of packets required. Advise that teachers should expose students to methods of obtaining Z values from the table, and also guide students to find probabilities that exceed given value. Then question 16, it says 2 points A and B are on the same horizontal ground. A particle P is projected from A towards B with an initial speed of this at an angle of 30 degrees to the horizontal. 2 seconds later, another particle Q is projected from point B towards A with the same speed and at the same angle of elevation P as P. If the particles collide at a height h above the ground, determine the value of h and the distance between the points A and B. So we shall need to come up with a sketch of the two motions. So for particle A is that, then B is that. So they move, this one moves, and after this one starts, and they meet. they meet at a height h, and that's what they want. So the horizontal distance covered by particle A is x1, and that by particle B is x2. But they both cover the same vertical height. So considering the vertical motion for particle P at point A, we have h is equal to 49, which is u.t sine 30 minus a half gt squared, which is equation 1. Then for particle at point B, it used less time, so it is t minus 2, the time, but the rest are the same. So expand, simplify to get the equation 2. So there are two equations, two unknowns. We shall first equate the two to get the value of t. So when I equate, I'll come up with this. Therefore, t is that. Before we go to the next slide, let's see marks for this slide. Then for the next slide, we can get now the value of h from either equation 1 or equation 2. So h will be 25.725. Then for part B, they said the distance between the points A and B. They want x1 plus x2. So distance at B is x1 plus x2, and x1 is given by this, x2 is given by that. So we know the value of t, we can substitute for t and get the output. And that's what they wanted. So the question in part A required candidates to find the height at which the particles collide, and part B determine the distance between the 2 points. So the weakness was failure to resolve the velocities horizontally and vertically, and also to use appropriate equations of uniform motion and apply the condition of collision. So advise that teachers should help students to demonstrate how to obtain the directions of velocities by resolving horizontally and vertically from correct diagram. Then also guide students to explore the various methods of finding the two horizontal distances that lead to the range. And also emphasize the conditions of collision both horizontally and vertically. So basically that was the paper for Uneb of the year 2022, and these are the general remarks that the questions were from the topics mechanics, statistics, and probability and numerical methods. So like I told you, in mechanics, 3 questions come from section A, 3 questions are in section A, and 3 in section B for mechanics. Then statistics and probability, 3 section A and 3 section B. Then for numerical methods, there are 2 section A, 2 section B to get 8 section A and 8 section B. The performance in 2022 was better than that of 2020. Remember, 2021 there was no Uneb. The quality of work presented by the candidates was also better than that of the year 2020. The paper was of the same level of difficulty as that of the previous year. And these are the well done questions, poorly done, most attempted, least attempted. So basically that is it, and I hope that this video has been of great use, and I hope that you will not do the same mistakes which was done by those in the previous year. So 1, remember to carry a long ruler. Then 2, remember that in a Uneb exam, there is no borrowing. come with whatever you'll need to use and don't borrow. Mathematical logbooks are provided by the school. You can't say that I'll buy my own. Then the pens to use, it must be black or white, black or blue. Somewhere where I facilitated, I saw students use a green pen. It is very, very abnormal. So it is not needed. It's actually an abomination to use a green pen, because even an examiner cannot use a green pen. A green pen is only by the Uneb officials, the ones called the chiefs of the papers. So never carry a green pen in an examination room. 2, never carry a red pen in an examination room. It must be blue or black. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on marking guide for physics paper 1 for Uneb 2022. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family.